our topic for chapter 5 is moving loads. From the previous section, we see that the maximum moment occurs at the point of zero shears. This is referring to the previous topic, the shear and moment diagram units. So for the beam loaded with concentrated loads, the point of zero shear usually occurs under the concentrated load until the maximum moment. So if we are going to recall, if you have the beam with the concentrated load, where is the location of the concentrated load, that is the location of the zero shear, and of course that is also the location of the maximum moment. So meaning, if this load P here is moving, so we assume that the load P is situated in that position, then the same, if where is the location of that load, that is also the location of the zero shear. And of course, the same location is the location of your maximum moment. Beams in girders, such as in bridge or an overhead crane, are subject to moving concentrated loads, which are at fixed distance with each other. If this is the bridge girder, so dadaan dito yung sasakyan, and yung sasakyan is considered a moving load. So here, itong wheel load natin is considered as a moving load, and of course this has fixed distance with each other. Wala ka namang sasakyan nakikita na nag-iiba yung distance ng pagitan ng dalawang gulong. Topic 5.2, single moving loads. For a single moving load, the maximum moment occurs when the load is at the span, and the maximum shear occurs when the load is very near the supports. Usually we assume this load lying over the supports. So for the single moving load to create the maximum moment, that single moving load should act at the midspan. And para mag-create naman siya ng maximum shear, we position that single moving load lying over the supports, either dito or dito sa kabila. So this distance here is L over 2 because this is in the midspan. So this position is the position for the maximum moment, and this position here is the position for the maximum shear. So what is the reason kung bakit na-determine itong mga positions na to cause the maximum shear and the maximum moment? Okay, so first we position the single moving load at the midspan. So this load is acting at a distance of L over 2. Now for this, the reaction of the support will be equal to P over 2, and on the other side is also P over 2. How? For the shear diagram, we would have this. So the shear in this location as the maximum value of P over 2. Now, if we are going to move our load over here, let's say at a distance of L over 4. Now it would change the value of the shear, and now if this is L over 4, then the other side has a distance of 3L over 4. And this, now computing for the reaction here, for this position, we are going to summate moment as if this is point A and point B. B is equal to 0, taking the clockwise direction as positive. Now, we will assume this as RA, that's the reaction at point A, and that will create a clockwise rotation with respect to point B with the distance of L. And this P here would rotate counterclockwise, so that's negative P multiplied by the distance of 3L over 4. That is equal to 0. Now RA is equal to 3P over 4. So since the reaction here would be equal to 3P over 4, then the shear at this point is equal to 3P over 4. Now, that would make this shear at this point as negative P over 4. So, ano yung napapansin natin dito? As you can see, if we are going to move our load closer to the support, it would increase the value of the shear. So as the load is moving closer to the support, or we assume that our load is lying over the support, that would be the position to create the maximum shear. So how about the moment? So for the moment, let's create the moment diagram out of this. So for the moment, we just take the area of the shear diagram here. So that's 3P over 4 and the distance of L over 4. So the moment at L over 4 is equal to the intensity of the shear multiplied by the distance. And that is just the area of this rectangle here. And that is equal to 3PL over 16. And the moment here is equal to 3PL over 16. Now computing for the area of this rectangle here on the other side, that is equal to negative P over 4 multiplied by the distance of 3L over 4. And that would give us negative 3PL over 16. Now, 3PL over 16 minus 3PL over 16, and that would close our moment diagram. And if we are going to compute for the moment, and if we are going to draw the moment diagram at the distance, that is just equal to this area, the area of this rectangle here, and that is just equal to P over 2 multiplied by the distance of L over 2 is equal to PL over 4. So this would be our moment diagram. So to have the visualization of the change in the moment if we are going to move our load closer to the support, so if the load is positioned over here and this would be the moment. And if we are going to position our load somewhere here, and this would be the moment. As you can see, if the single moving load is moving away from the support, the value of the moment increases, and at the midspan, that would be the position where the maximum moment occurs. Topic 1.3, we have two moving loads. First, i-define natin, gagamitin natin dito mga notation. We assume that the PB is the larger load, while the PS is the smaller load. And of course, the P is the total load, which is equal to the sum of the PB and the PS. Now, for two moving loads, the maximum shear occurs at the reaction when the larger load is over the support. So, in order for us to compute for the maximum shear, what we are going to do is to position the larger load. So in this case, the larger load is the PB. We position the larger load over the support. So that would be the PB, and of course, hindi naman nagbabago itong distance na to because fixed yung distance ng dalawang gulong. So sasama itong isang gulong, which is the smaller load, PS. Now, just compute for the reaction at the support, and that reaction is just equal to the maximum shear. How about the maximum moment? For the maximum moment, we will be using this formula. We have the maximum moment is equal to PL minus PS multiplied by D, and that's quantity square over 4 PL. So the P is the total load, the L is the span, and PS is the smaller load, and D is the distance. Now, for that moment, or that maximum moment, is created by this larger load. So what if we are asked to compute for the moment created by this smaller load? So this would be the formula for that. So since this would create the maximum moment, so the moment created by the smaller load is just equal to PL minus PB multiplied by D squared over 4 PL. As you can see, magkamukha yung formula niya. Ito lang po yung magkaiba siya. And for manual computation for this, we will apply the idea in the next topic, which is 3 or more moving loads. Topic 1.4, 3 or more moving loads. So in general, the bending moment under a particular load is a maximum when the center of the beam is midway between the load and the resultant of all the loads then on the span. With this rule, we compute the maximum moment under each load and use the biggest of the moments for the design. Usually, the biggest of the moments occur under the biggest load. So, paano natin ito ilalatag sa beam? If we have simplihan muna natin, So, dun muna tayo sa 2. Kasi it is the same, The same yung idea doon sa 2 moving loads at yung sinasabi na dito. So, if this is the PB and this is the PS, ito yung scenario natin kanina sa last topic natin, sa 2 moving loads. And this is the fixed distance. Now, what we are going to do here is to compute for the location of the resultant of this load here, and that would be the total P. Now, alamin natin yung distance ng X na to galing sa load natin or galing dun sa gulong natin. Now, according to the definition, sinasabi niya dito na the bending moment under a particular load is a maximum when the center of the beam is midway between the load and the resultants of all the loads then on the span. Now, if this is the center line or the mid-span, and we are computing for the maximum moment created by this larger load here, ang sinasabi niya dito ay ilalagay dapat yung center line is midway between this load here and the resultant of all the loads. Now, ganito yung magiging itsura niya. Ilalagay natin dito yung load PB, and of course, dito ngayon mag-fall yung resultant natin, and this distance here is half of this X. So that would be X over 2 here and X over 2 here. Now, alam naman natin fixing distance na to, then that distance here would be equal to D minus X. At a distance of D minus X, doon naman natin ilalagay yung isang gulong, which is the PS. Now, in this condition, the moment created by this wheel here, so and in this case, what we are going to do is to compute the moment at this point. So what would create the moment? The moment would be created by the reaction at this support multiplied by this distance to this point, or on the other side, it would be the sum of the moment created by the reaction at the support and the moment to be created by this PS here. So it's your choice whether to choose the left side of this load here or the right side of that load. Pareho yung moment na makikreate nun. What we are talking about here is the position, that is the position where that larger load here would create the maximum moment. What if we are investigating the moment created by the smaller load? So what we are going to do is, first, syempre, ino-note natin where is the location of the center line or the midspan. Then, if we are going to investigate or to compute the moment created by the PS, what we are going to do is to position the center line midway between the PS and the resultant of the load. So, in this case, ilalagay natin si PS dito. And, of course, dito ngayon magpo-fall yung resultant or the load P. And this distance here would just be half of this distance from the resultant and the load under investigation. So this would be D minus X over 2, and this is D minus X over 2. And we have here the distance X, which is the location of the larger load to the resultant. So this X here will be used in order for us to locate saan banda magpo-fall yung larger load. Then we are going to take the moment at this point. So the moment on the left side would be created by this reaction, and thus the larger load would create a moment at this point. So that would be the value of the moment, no? That would be created by the PS. And if we are going to consider the right side, ito naman siya, no? So that's the reaction at point B. The reaction at point B will be used in order for us to compute for the moment here. So again, it's your choice whether you are going to take the left portion if we are going to cut at this section or the right portion. Pareho po yung sagot na lalabas nun. Now, in this case, ang pinag-uusapan natin dito ay 2 moving loads. And of course, the same po yung principle nito pagdating doon sa may 3 or more moving loads. Tingnan natin. So, if we have 3 moving loads per se, this is P1, this is P2, and this is P3. Now, the first thing that we are going to do is to locate the position of the resultant, which is the load P. No, so, kahit saan lang yung basis natin, no, kung nag-base tayo dito, then this would be X. And if this distance here is D1, then this would be D1 minus X. If this distance here is D2, then this distance would be equal to D2 minus X. No? So, if we are going to, isa-isa kasi natin itong i-investigate. What would be the moment created by P1? What would be the moment created by P2? And what would be the moment created by P3? So, if we are talking about P1, then we will position the P1 and the resultant midway between the center line or the midspan of the beam. So, this would be the location for the P1, and this would be the location for the P. And this distance here is just half of this distance, so this would be X over 2, and this would be X over 2. And of course, since fixed naman yung distance, no, na D1 at saka distance D2 nung dalawang gulong, then we can now determine the position of the P2 and of course the position of the P3. So in this case, we will be taking moment at this point in order for us to compute for the moment created by P1, no? And kung yung left side ng beam yung pipiliin natin, what will create a moment here is the reaction at point A. So, mas madali siyang i-compute kasi isa lang yung kino-consider natin doon. But, on the right side, what we are going to consider is the reaction at point B and the moment to be created by P3 and the moment to be created by P2. So, tatlo yung kino-consider natin doon na mag-create ng moment sa point na to. That would be the moment at the load P1. Now, the same procedure to be used para kay P2 at para kay P3. Basta we are considering the loads under consideration if sa P2 na tayo, and the resultant of all the loads, hahatiin lang natin itong distance nila and ipo-position natin yan yung kalahati ng distance dito with respect dito sa ating center line or the midspan of the beam. Now, we would have the moment created by P1, the moment created by P2, and the moment created by P3. We are now going to compare the values of these 3 moments here, and yung pinakamalaking moment, that would be considered as the maximum moment to be used in the design. Pero usually, no, yung pinakamalaking load, yun yung mag-create ng maximum moment. But to be sure, we have to do the computation in order for us to do the comparison. For the maximum shear occurs at the reaction where the resultant load is nearest. Usually it happens if the biggest load is over the support and as many as possible of the remaining loads are still on the span. So usually yung ginagawa natin in order for us to compute for the maximum shear, nakukuha natin yung value ng maximum shear if the resultant is nearer the support and as many as possible the remaining loads are still on the span. Kasi there are possibilities that if we are going to so in this case yung P1 yung pinatong natin dito, no, sa support natin, and nangyayari kasi na if we are investigating this P2 here, ipapatong natin siya dito sa support, and of course si P3 nandito, yung P1 ay nasa labas na siya ng span. So in this case, magpo-compute ulit tayo ng panibagong resultant P, no? Na kung saan ang consideration natin sa resultant P na to ay si P2 at saka si P3 lang. And then we are going to compute for the reaction here, which would be equal to the shear. Now, actually, gagawin natin to, no, para lang i-investigate. Pero usually, yung case na to, ito yung mag-create ng maximum shear. Kasi lahat ng load natin ay nandito pa sa span. But we have to do the investigation. So, isa-isa natin ipapatong yung mga loads natin dun sa support. And then, let's see alin yung mag-create ng maximum shear. So, yung pinakamalaking, if this is the RA, the reaction to support considering the load P1, the reaction at the support considering P2, and the reaction to support considering P3, the larger of these shear here ay i-consider natin na maximum shear, no? So we have to note also that in determining the largest moment in shear, it is sometimes necessary to check the condition when the bigger loads are on the span and the rest of the smaller loads are outside. Kasi if we are going to compute for the maximum moment, what we are going to do is the position, diba? So kung nandito yung larger load, ayan, si P1, and this is the location of the resultant, there are some cases na yung ibang gulong, no? So there are some cases na yung ibang gulong ay hindi na siya pasok dun sa span, no? And we have, ayun na yung sabi ko kanina, na if this is the condition, then we will recompute. Magkakaroon ulit tayo ng panibagong resultant P, and that resultant P would just be the sum ng mga natirang load dun sa span. And meron akong nasalubong na lahat ng gulong, kung ganito yung case, meron akong problem na nasalubong na if this is the P1 and of course this is the center line, nandito ngayon yung resultant, meron akong problem na nasalubong na yung mga loads, yung ibang gulong ay nandun sa labas, no? In this case, since mag-isa lang siya, babalik tayo sa idea ng single moving load. Para mag-create siya ng maximum moment, what we are going to do is to position this P1 over the mid-span para mag-create siya ng maximum moment. and wait for the next video. So this ends the introduction, and yung next video natin would be the sample problems para dito sa moving wheels.